Hi everyone, we're here to talk about electricity, and the step 0 fundamental concept we need to talk about is current. Current is defined right here. Basically that symbol I represents our current, and the SI unit for current is the ampere, and it's really defined as the amount of charge that flows past a certain area divided by the amount of time it takes for that charge to flow. And that is no surprise because this is exactly the same as the way we define fluid flow. It's also the exact same way we define heat flow. It's also the exact same way we define diffusion. All these things are ways of representing the flow of whatever it is we're interested in. Electric current is no different. In fact, we talk about current in different contexts, right? We talk about it with water, rivers, the ocean, currents. Even we talk about air currents. Basically, we're still talking about the flow of something. And so now, even though we're talking about electric current, we're talking about the flow of electric charge. That's also why often you see analogies made between electric circuitry and water. So, you've got a battery that's driving the flow of electric charge. That's represented by a water wheel. It's the circuitry is represented by conduits that carry water around. Pebbles represent a resistor, different things like that. Really, because that's just leveraging this analogy that's basically behind the definition of current. Basically this picture here is called a schematic. It's the simplest possible circuit you could have. Basically you've got a load, which represents your toaster, your iPhone, whatever you got plugged in the wall. You've got a voltage source down here. That voltage source in this picture is represented by a battery. That battery, looks like a bunch of parallel plates, and that's kind of by design. It's supposed to kind of remind you of a bunch of capacitors, in the sense that it's something that has a lot of charge inside of it, and that charge wants to get out. Now, of course, the internals of a battery that are kind of all this electrochemical complication. But nonetheless, that's the basic idea, is that a perfect battery maintains a perfect voltage. Now, every battery will drain, and that after a period of time. But the better a battery is, the better it is at holding this voltage at a consistent rate for a long period of time. The voltage source is also called electromotive force, which is an unfortunate misnomer. It's kind of coined before. People have really set aside the use of the word force for the thing that sits on the left-hand side of Newton's second law. And nonetheless, the convention is very, set, and so you'll just have to get used to it. Just remember, when you see electromotive force, that's not a force, it's a voltage or a potential. So you've got some source of electromotive force that drives current through the circuit. Now, one of the interesting things, kind of a historical side note, is that when Benjamin Franklin was originally deciding on which direction the current flowed in a circuit, of course he had no microscope or anything. He couldn't actually tell. He just had to guess which direction that the current flows in a particular circuit. Unfortunately, he guessed wrong. And that's why the fundamental carrier of electricity, the electron, is a negatively charged particle rather than a positively charged particle, because Benjamin Franklin guessed incorrectly. He rolled the dice and lost. And so that's why when we talk about current, we're really talking about conventional current, the Benjamin Franklin current. The actual physical flow of electrons is in the opposite direction of the current that we'll talk about. Now, typically, in electronic problems, it makes no difference. It doesn't matter in the problem whether the charge is flowing to the left or the right. So very, very, very infrequently does this even matter. But there are a couple cases where basically it's a combination of an electronics problem and a mechanical, physical problem. Maybe you've got a cathode ray, a CRT tube or something like that. That might be an example where it would matter. But fundamentally, it makes no difference. It's not something you have to worry about. It's just kind of a historical footnote.